time for another brainstorming session. For my own purposes, I feel like it's going to be helpful to start stating the date at the beginning of these. So starting now, I'm going to do that. Today is March 24th. So what I have today is a little different. I have already done some brainstorming. It was on a whiteboard session instead of talking out loud. But I want to get you guys caught up on it if you're following along. I also think it's going to be valuable to me to go over all the same ideas again, but in this format. Because even though I've come up with the ideas, this format of speaking out loud helps me to vet them, and sometimes trying to explain something into the mic just snaps stuff into view for me. I've been enjoying it. It's been helpful, so I'm going to do it now. But before I can show you what's in the whiteboard session I just did, I also need to spend just a few minutes catching you up on what I have done to the story graphs and the story machine that runs them since the last time I talked about the computation model. So I'm going to start by filling in some details about what's happened there. Okay, so a couple of videos ago, I started toying with the idea of turning this into more of a VM. And since then, I have taken that idea and pushed it pretty far. So I'm going to tell you a little bit about how the VM works, and I'll tell you a little bit about how it's doing well, and then where I managed to push it to its limit and start breaking it, and those breakage points will be the jumping off point for the new ideas. So what's been working and what I've built is I have these story graphs, right? When you're in a story graph, you're on either a state or a path. The states are like the dots of the graph, the vertices of the graph. The paths are the arrows, so the edges between my vertices are directed. And currently there's no rule about it being acyclic, so it can be an arbitrary directed graph. In fact, I can have multiple paths that go between the same two nodes if I want, or the same two states. I call all of these things, all of the states and all of the paths are also nodes. So nodes all have shared properties like they can have story content attached to them. Or like game content attached to them, however you want to think about that. And then there are rules in the story machine that look at what's the current node we're looking at and decide how to update the state of the machine from there. So if you're on a state, it looks at what paths are available, and if it gets instructed to walk down one of those paths, it moves the current node onto a path. If that path doesn't have anything special, then it'll just automatically move on to the destination to the path, but the path might have some content, or it might have an instruction to push a graph. And then there's a stack of story graphs, which was introduced more recently, and there's this idea that when you're on one of these nodes in the graph, you can push a graph on to the stack. And when you push a graph onto the stack, you jump to its initial node, and you remember where you were at in the graph you left behind. So you remember what node you were on, and you can then see like you're on the top of the stack is different, and so you're now walking through a different story graph. And when that story graph reaches a point that pops, so any of its nodes might pop. When you reach a pop, what'll happen is you go back down the stack. So you drop the state of that current story graph. You lose your position in it, like you're returning from a function, and you go back to the position in the original story graph, and you advance from there. So when you pop, you can send back a code that's like, okay, please advance along this path or that path, or update the state in some way, right? Some instruction. The return code tells the story graph underneath how to evolve its own state. Sort of like how a function call, when it returns, that return influences the behavior of the thing that called into it in the first place. So that's all in there. And then the part that became more of a VM is that now when I want to do something like popping, before I was having a problem where when I would pop back to a state node, and that state node had some special coded handling, it wasn't going through default handling, but it was going through special coded handling, I was still running into this, like my abstraction doesn't fit in. Well, I switched to, when I pop back to it, some instruction there directly modifies the whole machine. And really, when I started thinking about it and playing with it, a function that takes in just the machine, like the story machine, and modifies its state is basically the same thing as an instruction at a certain level, right? In a classical VM, what you have is a bunch of opcodes and a switch that can implement all of those, and then usually like a built-in function opcode. And the built-in functions are usually just a function that takes in the state pointer, where the state pointer is the state of the whole virtual machine, and that function can do whatever it wants. It can manipulate the state somehow, and so it basically becomes another implementer of an instruction that isn't a part of the opcodes but can be implemented some other way if you escape out of the virtual machine itself into like, you know, the surrounding language or whatever. So these functions that take in just the machine pointer, just the virtual machine state, are kind of just an implementation of instructions. So I only built that. I didn't actually build like a full bytecode yet. There's nothing like that. I just went with like, okay, I'm going to have a function for incrementing and a function for setting some state. And they're kind of equivalent to instructions in the sense that they do stuff that you would usually put at the level of an opcode or an instruction. But I haven't bothered to develop an encoding for all of that yet. It's just everything is implemented as a built-in function that manipulates the registers and manipulates the memory on the machine and stuff like that. And that includes things like pushing and popping, all of that. Now, I don't have, like, there's no return pointer. So if I push a graph onto the stack and then that graph pops back, it's not like there's a spot on the stack remembering where to return to in the stream of instructions on the previous node. So that's not a thing. It's not like a function call. Instead, when you push, you also have the option to override the default handling. So there's default rules about what happens after a pop, and then you can override that with an instruction function, basically. You can say like, oh, here's the thing to do. Here's how to handle a pop. And I haven't actually used that or played with it much, so I don't know if that's good or bad. It feels maybe bad. It might end up being better if I just have a return instruction pointer so that it works more like a function call. It kind of feels like it might be headed in that direction. But I'm not committed to that yet, and there's no need to resolve that because it's not something I've played with, and it's not where things are breaking yet. And if it does start breaking there, I don't think it's actually going to be that hard of a change to switch to thinking of it more and more like just a regular old function call in a regular old VM. But that's the update on how the thing currently works. So now let me pivot to telling you about where I pushed it to and how that broke it. Okay, so in order to push it, I built out more of the story for the prototype game. And what I was building was this sort of scenario where you're in this scene where you've just arrived in town and you get some decision about how you want to spend your first evening in town. And so there's a couple options you have. You can go find an inn to stay at. You can go find a tavern to hang out at for a little while and mingle, or you can just go to the outskirts of town and pitch a tent and sleep for the night right away. And as I was building this, I wanted to have some additional interactions, some dialogue trees and stuff that you might go through, very shallow ones, but it's just ones to kind of introduce some of the rules of the game so you find out what the terminology means through a narrative vehicle. I wanted it to feel like you were being told a story still. So I don't just drop a menu of the most basic options of things you can do that actually update the game state. Rather, I want you to choose to go to the tavern, and then from the tavern, talking to the barkeeper or the bartender there, you learn about, what you can order or what rules there are. There's this rule at the tavern that the barkeeper there doesn't, or the bartender doesn't want you to just hang out and not buy something, but she'll allow you to, just pay a fee to hang out, and you can, drink water, and it's like a small cover charge. So it's one of the options you have in the game that you want to do the socializing from the tavern, but you don't want to pay for any of the other options, and you don't want any of the consequences of the drinking or something. So this is part of the, I'm not talking about the design of this particular game, but talking about the design of this particular game is important because it is going to, this is the piece where it starts to push on how things need to work. So there's one piece of this is how writing this works, but the other piece is how I want it to feel when it's being played. And I don't want you to have to, it should be possible to make the thing that's being played feel good without having to do a ludicrous amount of writing. That's a part of the design problem that I'm working on here. And a part of what doesn't feel good about this can be that when it's your first experience, I want to elaborate all of these dialogue options because it's the very beginning. There's a narrative reason why you should be, if this was a story being told to you and someone skipped over telling you a little bit about what this environment that you're in is like and what these people that you're interacting with are like, it would feel like rushed. Like you're telling me that I'm ordering a drink and you're not telling me about any of the things in between that kind of set that scene for me, make it give me a mental image or give me clues about where this is going in the future. None of that is present. And so the mental scene part is sort of like quality, just making it feel nice. Having those hooks in there, the opportunity to hint at things in the future is a little bit deeper. That's like important for making gameplay work too, because those places where there are hints about what might be coming in the future from a storytelling perspective are the same places where things will show up in the future. And the system needs to be able to sort of dynamically put those changes in. And I'm going to be able to get more specific about that when we start talking about the things that need to get fixed. I can get more specific about this idea of like what's going to be dynamic and what's getting added in or modifying in inside this system that I'm sort of alluding to right now. But another thing that happens is when this is your first experience, you kind of want the ability to explore your options and take stock of what you could be doing and not feel like you made a decision early on that you didn't understand its implications and you're locked into it. And a part of this is solved by the fact that I'm treating it like a roguelike, because that's kind of part and parcel of the roguelike genre is that, hey, you make decisions, they don't pan out, you die or you lose somehow, and then you play again. And the play again part is where you express the learning from the previous time. And so it's expected that you do stuff wrong, and it's expected that you that you will be repeating this in order to take it a different way to make informed decisions in future runs. So that helps somewhat, but there are still places where it felt like, there's no narrative justification for why the person in this situation couldn't choose to explore their options a little more. And it also felt like the interface just didn't justify that lock-in quite as much as it would have. Like, you get into places where, because you chose to go to the inn, you're now railroaded into buying a room. Like, there's no option to walk away and once you've learned the price and decide that you'd rather camp. That seems a little strange, but if you can only choose to either stay at the inn or walk away and therefore commit yourself to camping, what if you would also like to check out the tavern? Like, if you have the ability to walk away at all, then you should have the ability to walk away and do anything and walk away from anything and so on, right? So it starts to get a little bit tedious just filling in all those like back pointers. And at the same time, it didn't feel like a good interface anymore when you had to repeat these things the second time through, right? Once you've become familiar with them, having to go through the step of go to the tavern and then order a thing and then finally get to the interactions with the people there, that feels annoying too. Like, you kind of want it to start skipping ahead to I call it elision. I want it to like skip over the parts that were elaborated early on and become more streamlined. And in those cases, you don't need an option to go back because, one, you are already implicitly supposed to have had the experience of seeing the consequences of going down these paths in a previous iteration through this part of the story. And if it's already streamlined, then we're skipping the part where you go to the tavern. Once you've said you want to order the drink, having a go back button is more like time travel, whereas having a go back button when you enter the tavern is like walking out of an establishment. There's a narrative justification for being able to leave after you've entered. There's not a narrative justification for being able to unbuy your drink after buying it, right? So those things, you wouldn't need a back button on them, but you would need to find a way to like look ahead and say, okay, if you went to the tavern, then you would have these options. And so we can provide those options to you without making you do this intermediate step of going to the tavern. And how are we going to build a streamlined version of the interface and the elaborated version of the interface in the same system? Because I don't want to have to build two separate systems here, right? I want the system I build on day one and the system that I have for running the first interaction and the second interaction to be the same as much as possible. If I have to code up the buy ale button in two different places, that's two places that, that's an opportunity for there to be a mismatch in the logic that I miss. There's an opportunity for all kinds of like tedium in keeping all the different first time versus repeat options, and that's assuming that I only want a first time and a repeat. What if I want like a giant variety? What if I have a lot of ideas about how to procedurally bend and morph the options depending on what you know and what you can do and where we're at in the story, right? So it felt like the system was kind of working, and it was expressive enough to do some things like elaborate the text on your first visit to the tavern and then streamline the text on your second visit to the tavern. But it couldn't do these things like skipping the step of going to the tavern and going straight to buying something. And that felt like what I should actually be doing is more along that line. Like, the graph is good and helpful for structuring the paths through your options, right? The paths through the states of the game, but it was getting in the way when I had to make you stop at the tavern. So if there was this idea that you could stop at the tavern, or you needed to stop at the tavern the first time, then I didn't really have a way to do the elision so that I could skip going to the tavern completely through the graph, because I would then need some way to look at the paths that are available later down the line, right? Like, from the root node, I can see that I can go to the tavern, but I can't see that I can buy ale. And so the system just didn't have that in there. There's other problems like the options of what you can do are currently built into the content. And in a certain way, that's important that they can be built into the content. But I think it's also important that they're built into the graph. And I haven't quite worked out how I want to deal with that tension entirely. But it's at least clear to me now that I need to be building them into the graph. And maybe there'll be a way to eliminate them from the content and reconstitute them in a different way. But the ability to see like, oh, I'm able to go to the tavern, but nothing interesting is going to happen there. And from there, I can buy ale. So why don't we just say, go to the tavern and buy ale isn't an option from the root now when we're doing the elision version? Like, I didn't have any tools that would let that happen, because the content that was giving you what buttons that were clickable was built right into the content writing system. It had nothing to do with the graph. It wasn't inspecting the graph. It wasn't getting data from the graph. So that felt like there were some limitations in the structure that weren't allowing me to do these fancy things. And there are other things like, if I'm going to have these go back buttons, I might like to eliminate them. And I haven't decided from a gameplay perspective, just like from the perspective of what do I want the player to experience, whether or not I want these in there. But if I'm going to have them, it would be nice if I could have those without having to manually link up the backwards paths and the buttons. It'd be nice if that could be automatic too. If this idea of an undo could be a low-level thing, so that the graph itself doesn't need to say that there's an undo, but rather the graph looks like it only goes one direction, but the interface lets you go back if you've coded it to allow that, right? Like, if how do I want to describe this? Instead of having a forward arrow and a backwards arrow, I'd kind of like if it was good enough to just have a forwards arrow, and then the option to go back, if I do provide it, is sort of automated from the fact that there's no change in state that is permanent along that path, right? There's no commitment to something like buying the ale where you wouldn't allow a go back path. So it's more like just a do you want to allow go back, yes or no kind of question, rather than, okay, in order to go back, you need a separate path and you need to code up another button. Like I want that to be a little bit more built in. Okay, so those are the problems I was running into building out some of this stuff. Let's look at now the ideas I have about fixing it. Okay, so what I'm showing here is the sort of step-by-step plan I have of things I need to be doing to upgrade the computation model of the story engine so that I can fix some of the problems I was talking about. And I want to actually start with the last step here. So all of this is building towards these look ahead ideas that I kind of alluded to earlier, this idea of looking ahead through the story graph and skipping through parts of it that don't have anything to display to the user, but are just sort of structuring. Maybe they're there for introductory stuff that on repetitions wants to go away. Maybe they're there just for logical purposes. But one way or another, I have parts of the graph that I want to consider skippable from the perspective of what the user actually witnesses as they move through it. There's no need for the machine to ever stop on it, but rather it just contributes to structuring the computation and organizing the authorship of this thing. And the system kind of looks at it and looks through it to find where we're going. So that's the idea of look ahead. And I'm going to start by describing that because that's what we're building towards. And then I'll go back and show you how I think these other steps are necessary to get there. Okay, so here we have this idea of a choice tree. It's kind of in my head a generalization of like a dialogue tree. It's a tree that starts from a root state, and as you make decisions, you're kind of exploring this game tree, going down towards the leaves of the tree. And when you get to a leaf of the tree, we sort of escape back out of the tree to a larger game system. So you pick a final point, and that determines how the game state evolves. But all the things in between are there for flavor text. They're there for dialogue. So like in the example tree I have here, you start at the beginning of the evening. Maybe you choose to go to the tavern, and from there you can decline the bartender's offer for ale or spirits. And when you do that, you enter into the part of the dialogue tree where she explains to you that if you want to stay and hang out, she wants you to pay a charge, just to be around and take up space in the tavern. So you can then pay the stool charge. And the way this is structured, if I treated this as a literal story graph where there's no going back arrows, you can see that now you would get railroaded in. You might learn that like, oh, if I have to pay anyways, then I would rather get the ale than pay the stool charge if I'm gonna end up paying either way. And I didn't know that when I declined, so I wouldn't want, as I'm playing, to decline and then get railroaded into paying the charge and not getting anything for it. But the way this tree looks, it looks like there's no going back. And what I want to do is kind of say, that's not so true. There's the tree is a dialogue tree sort of structure. Its leaves represent game moves that escape outside of the tree structure. And the tree structure itself is sort of a tool for authoring the narrative vehicle that gets us to learn about those options. And maybe it's not so much important to think of this tree as strictly the paths you can take to arrive at these locations. We might allow for going back from some of them in the course of exploring the states, or we might allow for skipping over them once you've become familiar with your options and you just want to pick. Like if you know you want the ale and you're at the beginning of the evening, instead of clicking on tavern and then ale, if you're already familiar with the system, we want it to also be able to sort of look ahead and grab all those leaves and just make those leaves the options rather than forcing you to go through the details you've already seen. Now, that's my idea. I think a useful evolution of that from there is to say, okay, the structure that we author doesn't have to be a tree. As long as it's a DAG, that can still sort of stand for a tree. We want to remember here that when we're building this DAG now, if I, for instance, in the DAG I'm showing on screen here, you can go to the inn, you can go to the room, and then you can go to the tavern. So what that represents is something like you went and you got a room from the inn, you saw your room, dropped your stuff off, and then you went to the tavern, which is actually a different thing than going straight to the tavern. So it's not true that which path you take to get to the endpoints doesn't matter. What path you take does matter. So it's sort of like there are multiple endpoints at each endpoint, right? There are two different ways to get to the stool charge. One is to go to the tavern, do the decline, and then do the stool charge. The other one is to go to the inn, get to the room, then go to the tavern, do the decline, and get to the stool charge. And those two things might have different consequences, right? When you get your room, you've already paid 10 coins, so there's at least a difference in how much money is in your pocket, depending on which path you took. So it's not true that the end points always mean the same thing when you reach them. But it is true that there's only a finite number of paths that kind of take you from the route to an endpoint, and that endpoint, the consequences of getting to that endpoint are determined by just the path you took. So in total, the point is, if we want to, we can treat this as a tree, and we can also build it as a DAG, right? The DAG is just sort of an option for making building the tree more convenient when it would be useful to like reuse substructures within the tree, or to build a tree where we reuse some of the substructures, and the DAG is just the way we express the reuse of the substructure. This does slightly complicate the algorithm for look ahead. So before we could just assume that look ahead meant go all the way until a leaf, and that's where you have to stop. But now look ahead will have to stop a little sooner. So for instance, in this version, I can't look ahead past the room or past the decline node because they are sort of critical nodes. We need to know about them since they give us different paths to the same node. So there's some ways we could talk about this is like the idea of a dominating node from compiler theory stuff. We don't really need to get into that right now. I'm sure I'll cover it in more detail in like a more formal video because it's interesting stuff. But point is, we can still end up treating it like a tree in all the ways that matter. We can still do look ahead. It does complicate the look ahead algorithms a little bit, but I think that the options for the author and what can be automated for them through these algorithms are totally worth it. Okay, and here's another idea. So it's established that I'm going to be building these DAGs, but as I was thinking about sort of what I'm really trying to do with them, an important distinction between what I want to do with the DAGs in this system and how they're generally thought about in a storytelling, like interactive fiction engine, is that usually they're thought of as a flow from the beginning of the story to the end. So there's like an initial state, then there's all the intermediate stuff that can happen in the middle depending on the paths you take, and there's like some final state, maybe some final states depending on if you have different endings, right? But I realized that I'm actually telling stories that are, how do I want to describe this? I want some kind of reuse, right? So I want game loop in my system. I want that to be systematic. I've talked about that a lot. I also want this idea of reuse. And all of these things mean that when I build a graph, this is why there's a graph stack. I want to be able to reuse the graph. I want to be able to take a graph and stamp it out multiple times. So one graph can become a sort of mini story that gets reused. Either it's repeated because we are visiting it at different points along the way, like function call reuse, or it's repeated because it's sort of every time it happens as a cyclic pattern. Like if it's a day-night cycle, then the day part is repeating in that day-night cycle, right? And I think that is useful as a sort of like motif building thing from the storytelling perspective, and it's necessary from the game loop systematic perspective. And so I really want to shift perspectives here to stories that repeat. So even though I'm building a DAG, I want to conceptually say that there is a back arrow. I'm thinking it would be useful to have a strict begin. So I have an initial node already, and I think I want to keep that. I'm also thinking I want to have a strict singular end node, just to sort of organize things, kind of like how there are braces in a function. There's a strict begin and end. So we're building DAGs, but there's an initial node and a terminal node. And then there's this extra hidden back channel that's automatic. Every story is assumed to be a repeating story that's being told over and over again. It might not be being told back to back with itself, because there is this idea in the system that as the story is being told, there are more than one of these story graphs that are active simultaneously. And right now that's implemented via the stack, although I also have a lot of thoughts that probably this needs to get to the point where there are parallel stories happening. So to give an example of that, imagine the story of going into the tavern and leaving the tavern. That's the example that I sort of attached to this on the whiteboard here, which is like, you could imagine you have this big adventure, and a part of your adventure involves a number of visits to this tavern in town, and you could tell the entire story from the perspective of the tavern keeper, the barkeeper, or the bartender, whatever you want to call them, right? The person who's just sitting there serving you your drinks, seeing you interact with people there in the bar and then leave again. What would the story look like from their perspective? Well, that's kind of captured by one of these cyclic graphs where you have at the beginning of the story as you enter the bar, there's various paths you might take through that part of the story, and then you leave the bar, and that happens again later. And while you're away, the bartender has no visibility into the rest of what's going on in your life, what's going on in your story. And so from the perspective of this particular repeating story, it's just sort of in that back channel. It's in that neutral position where the story is not happening, but it is, I called it the neutral position because the story is not anywhere between its begin and end state. It's sort of, you're in the part of the story where that particular story isn't happening. And then it repeats back around and happens again. And I think that this structure, thinking about things this way brings about some of the other key ideas that I want to do a little differently moving forward, such as while this is a repeating story, things are changing. Every time you come in as a character to the beginning of one of these mini stories, you have a different state. You might have a different amount of stuff in your inventory or a different amount of money, which might matter in these cases. You might have different relationships with involved characters or different knowledge, different skills. The story itself might be primed to behave differently too. Like if you already know the person, their relationship with you will be reflected in the fact that they don't say as much to introduce themselves. They give a shorter greeting. They might refer to things that are happening in other parts of the story because they're primed to do so, right? The options of what can happen are different, both because of how you as a character are different, and also just because of how this particular piece of story evolves every time you interact with it, and also because of how the rest of the world might be influencing the behavior of the story. So all of this stuff, I want it to be possible for those things to come in and influence your paths through this story in some way. Okay, so that gave us a look at what the look ahead is about, and then that little back arrow that turns it into a cycle instead of a DAG, we can ignore that for the purposes of look ahead. Look ahead will end at those end nodes. That's a part of why there's a begin and end, is that's the realm where look ahead happens. The repetition is important for the whole to come together in a useful way, but the look ahead is an algorithm that operates within those bounds. Now let's look through these other steps that I have in mind. So we're trying to get to that look ahead plan, but there are some other things that need to happen for me to be able to do that. So there's a number of ideas here, and some of the early ideas are there because they're necessary to make the other ideas make sense. And so all of them by themselves are a little bit confusing, but if we get through them from beginning to end, you'll see that it is, I believe, a path from what I have so far to a vision where you can write these DAGs and automate some of the stuff like skipping over in between nodes that don't actually need to be visited during the current iteration, or automating undos and stuff like that. So the first big idea here is VM reversibility. So I've got two different ideas on how VM reversibility might be possible, or how I might want to implement it, I mean. The first idea is that I would introduce this idea of like a reversible instruction and then have an undo history. And so the idea here, as you can see in this picture, the look ahead bubble there is showing us how we're viewing the decision tree or the choice tree as a tree and not a DAG. Remember, it could be a DAG, but when we unfold it, we treat it as a tree for the purposes of like looking ahead. And as we're looking ahead, we're looking for nodes where we can't skip those nodes. And there's a couple reasons why we might get to a node that we can't skip. One might be that we just hard code it in. We want to be able to say like, hey, we want the player to stop here and interact with this every time they pass through this system so that we can deliver some content. But we don't, later on we will make it so that it's not an every time thing. We might want to be able to say on this particular instance, because it's their first time in town, they need to stop at the tavern node before they do the ale node. But once they've stopped at the tavern node, we want to be able to skip it in the future, right? We want to have that dynamic, we want to be able to dynamically decide whether or not there is content that is worth stopping here for, or whether the user should be able to just skip ahead. And the issue with that is, in order to know whether or not there's content there or not, I kind of need to run the VM. I need to look down all of the paths. And if I run the VM, I start changing the state. And yet I need to be able to run the VM down different paths, right? These are sort of different branches that the user might choose. And I want to look ahead through all of them, which means I want to execute them, see where they take me, see if when I go there, I dynamically end up stopping there to show content, or if I dynamically pass through it, right? I want the game state to make decisions like that, not the graph itself. I want the graph to always have nodes, but so in this picture, I have a node that's getting skipped. Like the VM is running there and it's executing the code to get there. And then as it executes, it sees that there's no reason to stop there. And so it looks ahead to the next nodes. And that's why I need the reversibility in the first place. Now, in this undo version of reversibility, the idea is there are just some instructions that are reversible, and they're reversible by means of pushing onto an undo history. They're like an instruction that could be run that would undo the operation, right? So it's basically like in a text editor or any other editor where you have some history that you can use to undo. As you execute the VM, the VM operations can do two things. If they're reversible, they can update the state, but they can also save the necessary information for undoing that change in state. And then some instructions don't have to be reversible, and those represent the spots where you have to run there for some reason. Like, okay, we're going to emit some content here, and since we're going to have the user stop and interact anyways, now if we use an instruction that cannot be undone, it's not an issue. If you do use one of these instructions that cannot be undone without putting some content there, that would be a content issue. And you'd have to like either devise a way to make the instructions undoable, or you'd have to, attach the appropriate content to kind of go present that situation. On things that can't be undone, might just be arbitrary. Like, in this case, I want to do a set operation, but I also want to mark it as just like if the player gets this far, I don't want them to click this and then undo it later. This is not undoable, or I don't want you to skip through this decision. I want you to always make this explicit. Just from an interface storytelling perspective, even at the most streamlined interface, you always have to interact with this node, right? So some of that is just authorship decision stuff, and some of it is like implementational. It might be that there's just certain operations that putting them onto the undo stack doesn't make sense. For instance, pushing and popping on the graph stack, I'm not really thinking of that as something that I want to undo. I'm thinking of undo as something that happens just for this look ahead. And look ahead is currently something I'm only envisioning as something you can do as you are walking the current DAG, right? And if the current DAG does a push or pop, that would break you out of this. I guess one thing to consider is pops in particular are kind of end states. Like if I were in a graph and I did a pop, the pop should probably mean, in addition to literally the graph machine or the story machine pops its graph stack, it should probably also put me into the neutral position. Like that should count as ending this graph, right? So I think that might be worth considering a little further. If like pop is an instruction, does a little more in this picture now, because pop really means end, right? It's that end of the DAG kind of state. Now I have a second idea here, and these are just sort of the two common ways to think about how to make something reversible in computing. One of them is you save operational information about what you did so that you can undo it. The other idea is you just keep snapshots of previous states. And so snapshots in this case, since I'm not trying to undo the graph stack operations yet, that might be, I have a suspicion that I might want to be undoing graph stack operations someday. Like I might want to be able to look ahead to a node that does a push, continue looking ahead through its DAG, find out that nothing in that DAG requires a stop, pop back, and keep looking ahead in the current DAG, all without forcing the user to interact with any of the intermediates there. That might become a useful operation. I don't know for sure, but it is interesting. So I don't want to rule it out. However, for now I'm assuming that is out of the question, that if there's a graph push, then you have to stop at least when you get as far as doing the push, okay? But that's we don't need to worry too much more about that. For now, the more interesting thing is saving the memory in the registers, because those are state that gets modified as you walk through the graph without doing anything to the stack, right? So assuming that look ahead only applies to the current level of the graph stack, I still need to be able to restore memory in registers. The idea is that a snapshot is just like a serialized version. It's two memory blocks, basically, that go out into like a separate data structure that can then be pasted back into the VM to restore the state. And so I've written down what I think the pros and cons of these different options are. So the pros to doing the snapshot version is going to be less maintenance difficulty. And what I mean by that is, as I'm running this project, if I'm building the VM and I'm giving it new instructions, if I have an undo history kind of system, new instructions means I have to implement the undo of those instructions if I want them to be reversible, right? If I build a new instruction and it's just like helpful to build it in there, but it's also important that that one be undoable, then I have to go and do the like, did I carefully implement this? There's a bigger surface area for bugs as as the number of instructions grows, the number of opportunities for undo bugs grows linearly with the number of instructions. You know what I mean? And then the other pro to the snapshot version is that this would be much easier to serialize. So if you wanted to save the state of a VM and restore it, this is sort of built into the snapshot version is closer to that. And so if you're going to serialize out like, points of state that we've been at and kind of put them to disk for purposes of restoring them, and you want there to be some kind of mutual alignment between the runtime undo system and like the larger undo system that goes out to disk and back, this lines up with that a little better. There are cons to this, though. The big one in my mind that is almost good enough, although I'm very torn on this whole thing, but one con to this is that if you go this route, you end up in a situation where you can no longer use pointers that are like reference things from outside the VM. And I don't really mean reference things from outside the VM, because that's not true. What's really a problem is if you have a pointer to say you have a linked list and you have that contained within the memory of the VM. So it's not jumping out of the VM's memory. It's entirely inside the VM's memory. But you want to use pointers that use actual CPU memory, not VM offsets. That doesn't work anymore, right? That works fine in the other case because the undo history doesn't care. It doesn't restore things by shifting their positions around. In this case, it does break. So as long as the memory of the VM stayed put, this wouldn't be a problem. But as soon as you had like a growing arena for the memory that could, potentially be relocated when it shrinks and grows again, this would totally break. And in fact, doing full snapshot recovers into such a situation would break anyway. So like the serialization benefit only comes into play if you use strictly offsets and stuff. And so I don't know, I'm torn there. The offsets thing is cool if you want to make this thing completely self-contained. And well, it's just that becomes harder to code to. You have to do all this offset work. So building a linked list, I don't know if you've ever done this, but if you go and try to build a system where you have a linked list, here's how to run the experiment. Go to a 64-bit computer, build a linked list where the nodes all have 32-bit offsets. Like you have an array of nodes, and so you can use integer offsets to find your node instead of pointers. And so your next pointer and your previous pointer get replaced with the index of the next node and the index of the previous node. And then you try to build your linked list or your tree or your graph, whatever data structure you want. Using that limitation, that is very similar to what this would be like, because you can no longer use the actual like C-level pointers. You have to do everything through these offsets. And so coding to that just becomes kind of annoying when you want to use the C language part of the system directly. And I don't know. So that's like a downside to this. The other one is that if you want this to go as fast as possible, this does cap out sooner, and so that's a potential problem. I don't know how important that is. I'm not convinced that this needs to go as fast as possible right now, but I don't know. The more performance you have, the more magic you might be able to unlock with a system like this. Yeah, it's hard to say. So my gut instinct is to do the snapshot version first and use that as the baseline because of the maintenance burden stuff of an undo system. But I don't know. I don't know exactly what the right thing to do is there. That's why I have to share two different versions. Anyway, let's get back to the outline of the whole list, and I'll show you some other parts of what I need to work on. Okay, so we already understand why we're going to do DAGs with a story or a start and an end node. We looked at that before. The next one to go over then is the third one. What's the stuff about the state that's local to the story graph and supporting multiple instances of that? So first of all, the reason for wanting something like this is just that I want to be able to have the iterations of the story, right? We're thinking of these as stories that repeat now. And I want the repetitions to not be exactly the same every time. I want to tell the story, but have the way it's told evolve and maybe have some of the details of what's possible within those repetitions evolving through the story, right? I want to build into a single graph the structure that shows what story we're telling and also program into it the sort of the way that it changes on repeated visits, right? And so local state seems like the right way to do that. That can, like right now, I've already got a way to do this built into the prototype I've built. And what basically happens is there's various spots along the story graph where I have counters that I increment. And I then use those counters to change the way someone interacts with you. So for instance, the innkeeper knows that if you've never stayed at the inn, he's going to talk to you a little differently. He's going to remind you of what the price is and ask if you want a room. If you've stayed at the inn, instead of reminding you what the price is by saying one sentence, you've stayed there before, so it's like for another night. And you wouldn't say for another night it's blah if you haven't stayed there yet, right? If it's $10 every time, he's still not going to say it's another $10 when you've never stayed there before. So there's this global game state, and by global I don't mean it's literally global in my C code. I mean it's global as in there's a game state struct and all the variables in there are available to every part of the system at once. The part of this that says like mem in these pictures, that part basically means the game state memory. And the story graphs kind of just look into that game state memory and read it and write it to dynamically decide what's going on and how to change what's going on. So they'll increment a counter when you visit certain nodes in the story graphs, and it'll change what it shows you or the interface it provides based on what's in that state. But it does this through, like I said, global, as in variables that are just thrown in top level. They're visible from everywhere and they're just all in a giant list. It would be nice to start being able to say things like, this variable is just local to the story graph, so that as you're writing a particular story graph, you can kind of have some local state there that describes the state of that portion of the story and how you've interacted with that piece. So if there's a character like an innkeeper who you're only going to interact with in your story when you go to the inn, then stuff about your relationship with the innkeeper can kind of just reside there as hard-coded state for that part of the graph. And in a way, like building this into the VM is a little bit extra. If I was going to go to the point of having a full compiler for this stuff, I could just say like, hey, we need some kind of register, save, restore logic somewhere in the system and a way to do that. And that way, when you're at the end of a graph, you get to the graph node that does a pop, you just run the register restore so that the registers are back the way they were before, and you just make this like a generic thing, and then you pass in a pointer. Essentially, you pass in the offset to the block of data for the graph you're going to run, and say like, here's the data, here's your local data, here's the data relevant to this thing. You could also just, if there's only one instance of each of these data blocks, you wouldn't even need that. You just have like constants that are like, here's the offset from the whole game state. However, I do think you probably want, in some cases, multiple copies of the data. There are reasons why that could be useful for certain kinds of storytelling situations, or where you want, for instance, like a combat loop is the kind of thing where you might want a relatively highly reusable combat loop where the stuff you're plugging in isn't the same all the time, but you might want to save a copy of one of them in order to resume it later or something, right? There's interesting ways to use the ability to have separately saved blocks of story state within the whole state. And then the idea would be that as I'm writing the bytecode, since right now I don't have a compiler, it is useful to have the stack keep track of the current state of the story graph at the top of the stack, as well as the pointer, which is like an offset to the data that is local to this graph, and then having all of my bytecode that deals with memory operations, so reading memory and writing memory, would all now have a local variant version, where local just means, hey, for memory operations, go read that local register thing that lives at the top of the stack and put that in to offset the address we're using. So when you do a local set and you use the address of 0, you're actually saying whatever variables at the beginning of the block for this particular story graph, not whatever variables at the beginning of the entire block of game data. And this is a kind of, I'm torn on this. Like I said, if you had a compiler, you could do all this without needing special opcodes. But as I'm currently handwriting the bytecode and I kind of want to stick that way for a little while, it lets me iterate on the design of the main concepts without having to get bogged down in building a language, like a textual language. And there are other things that I'm unsure about in the system. And like I know textual languages are possible, so there's nothing to learn that's like uncertain in that direction. It's more just how to that would just be more of a what to learn based on stuff that's already known, but there's nothing novel in that direction that I need to answer. There's no unanswered questions in that direction. So I don't really want to get bogged down on it, and yet to do some of these things without getting overwhelmed with the amount of extra work it would take to do a common operation like having local state, I think it would be useful to build this into the current version of the VM. I'd have to keep in mind to reevaluate something like this later if I was going to push things farther and have a compiler that might generate the bytecode from a higher level source language. Then this bytecode option might not be so useful. Another comment I want to make here is that this has a certain flavor of object orientation a little bit. There's this coupling in this idea between some special state and the code that operates on that state in a sort of object-oriented sort of way. But I think of it a little bit differently. What this actually feels like to me is more like local statics in a function. So setting aside the fact that there are multiple instances of these sometimes, what I'm really talking about here is each story graph is a function, and it's not a function that you execute all at once, but it's a function that describes how the story state evolves as a player moves through it. And so it's like a function, and having state that is local to a function is like a local static, not like a member variable on an object, right? And there's not like two different ways to call a story graph. The story graph has these states which are distinct, but they're not like function calls. They're not So if it was like object-oriented programming, it would be a kind of object-oriented programming where each object only has one function or something. So anyway, it's not quite object-oriented programming. It's kind of got that flavor. It's kind of interesting to me. It feels like a useful trick in the bytecode more than anything else. But it's also just an important concept, I think, in how I want to structure some of the writing moving forward. All right, let's get back to the outline, and I'll show you the next piece. Okay, so what's up next is that I want to emit content from the VM, and I'm actually going to go ahead and combine that with like point number 4. I'm going to combine that with point number 5, which is to the encoding the reachability conditions of the VM. So let me show you what that slide looks like. So the reason I'm showing these together is because these two things that I want to achieve are kind of solved together. So and the picture that describes the solution for them kind of goes together too. Like they both have the same picture. The picture that describes the solution for one of them describes the solution for both of them. So so on the left-hand side, I have like some details about how the system works currently. So I have these story graphs. I've shown it as a DAG, but actually right now, as I said, it can be cyclic. Not irrelevant for this issue, but what is relevant is that I have two different things attached to each node. And so I have the path and the state in the graph, right? And they both can have bytecode and they both can have content. And then what happens is as the story machine gets activated, it goes onto a path based on which you sort of activate it by pushing it onto one of its paths from its initial state or from wherever it was left off. You push it onto a path, it runs some bytecode there, and then there might be content attached. And if there's content attached, it stops and displays content. Right? That's I have this list of VM rules there. So the first rule is if anything has content, you always stop and display it. And that's one of the things I'm trying to change, right? I'm trying to get to a point where there isn't a fixed idea of where you have to stop in the graph, right? We're building towards this thing where some nodes show up at the beginning to do some exposition and then they disappear. They become like structuring and patterning in the execution of the thing still, but they stop being explicitly narrative providing. They don't provide more game content as you pass through them in the compute model. So that's one thing that I want to change. But right now, the path can have some content. If the path does not have content, then the default rule, if the bytecode didn't do a push onto the graph stack or a pop off the graph stack or an explicit stop, then the other backup rule is that if you're on a path, you always continue to the destination state. So then the node goes there. And again, there's some bytecode, so it runs as soon as you enter the node, you run the bytecode. And the bytecode there, again, it might push, it might pop, it might explicitly stop. If it has content, we have to stop. But even if it doesn't have content, and even if it didn't explicitly stop, we always stop on these state nodes unless it did one of those like push or pop operations, right? And it stops because we think of the state nodes currently as places where we intend for there to be content and places where branching by the user happens, right? That's what I've been thinking is, oh, if this is a branching point, like paths aren't branching points because paths always end up in the same destination. But states are branching points. This is where we encode the possibility to go in multiple directions based on a user's choice. And the thing is that that means it says the default rule is stop, because even if you haven't attached any content, I wanted it to be like, hey, you're in dev mode. Right, you don't always want to finish all the content before the thing is runnable. So if you haven't attached content, we still stop anyways, and we just display the like dev fill in the blank version that is not really worthy for shipping, but it lets the system run and work in like a draft mode, right? And so in this particular setup, content is just like an optional attachment on all the different, on both path nodes and on state nodes. And there's no hint in anywhere in the graph about what's reachable given the state, right? So reachability means like, say you have an interaction like staying at the tavern that requires you to spend at least a certain amount of money, and some of the interactions require that you spend a little more money. And if you don't have the money for some of the interactions, then they're unreachable. And that's what I mean by reachability here. There's this notion of what can be reached. It's not just a matter of what path, like what can be reached through the graph, but also will the game state allow you to reach that? And right now, whether or not something is reachable is entirely encoded inside of the logic that renders out the buttons to the player. And this is where there is a little tension, right? Because I do think of this as a story engine that could generalize beyond text adventures. And that generalization isn't just an issue here. Like it's not making this issue, right? Even if I wasn't generalizing, this issue would come up. But I think the generalization clarifies the issue, which is that whatever gameplay you have, whether that's some text with interactability on it, so some buttons that you render out and some like flavor text that goes around and on those buttons, or if your game loop is a little more interesting, like it's an action game or it's a card game or whatever, the things that are possible from the game interaction interface depend on what that interface is and what's possible in that interface. So if the interface is a platformer and the jump height just doesn't let you reach a certain door, then a certain door becomes unreachable just by virtue of the platformer physics, right? And that I can't encode into the graph, right? Like that, to figure out whether or not like that would, there's no general solution for, is this game beatable, right? So that's not what we're talking about here. And there's always the possibility that the graph is missing information that would disqualify some paths. But what's interesting about reachability is that we're only going to be using it when we're looking ahead. So that means we're looking ahead through nodes where we don't have content anyways. And content means gameplay, right? We're talking about gameplay content. So any node that isn't one that's going to generate gameplay content might still have reachability conditions we want to check. Because we might be doing something like say, okay, you're at the spot where you can shop, and we want to see which things you'll be able to shop for based on what you already know in terms of what's available and the prices. And so if you're thinking about going to the tavern and you know it's $5 for the ale and you don't have $5, we want to look ahead and see that that's unreachable and hide it or mark it somehow as like it's shown but not clickable because of the fact that you know the price. Now, if you don't know the price, then that probably means you should be writing this in such a way the player has to go to the tavern, right? There's these interactions the player hasn't done, which would unlock that knowledge for the player. Like the player would literally the real player in the real world would know, but also the character in the fiction would know. And so it would then justify the skipping of that interaction in the future once you've shown that interface in the elaborate way. Once it's been shown in that way, we're skipping ahead by looking ahead here. So the idea is reachability isn't about what's reachable given the entire content of the game and what's happening, because there are these moments where we escape out of the story engine and into the gameplay. And in a text adventure, my gameplay is just you clicking on some buttons, so I could make those one-to-one. I can make it literally match. But so far, I've been tending towards rendering out buttons separately, like as a separate piece of logic. And I think that helps me to stay true to this vision that the story engine works, even if it's not a text adventure. What the story engine provides is in the spots where we no longer want to attach some content to some of the nodes in the story graph, we want to fix this so that the reachability can be encoded into the graph in those cases, right? So here's kind of what I'm envisioning that could be like. And I haven't built this yet. I haven't had a chance to test anything like this. So I'm just throwing at you the new ideas from the brainstorming session. Here we go. So the new system I have in mind is that paths and states will no longer be exactly identical in terms of what they can have. The new rule would be that paths have the condition bytecode, and when you're doing look ahead, you look at all the paths that shoot out from the current state, and any of them that have condition bytecode, the default is that you can take them; they are reachable. But some paths might have condition bytecode, and when you run condition bytecode has these special instructions called allow and disallow. And if you hit an allow or disallow instruction, that's the end of the execution of the condition bytecode, and you've made a final determination about whether or not that path can be taken. And so you can also have the default that, like, if you get to the end of the bytecode and no determination has happened, again, default to allow. So what this would mean is, from a state, we can look down the paths and execute each of the condition bytecodes on each of the paths and figure out which ones are allowed. And so we can now start writing some code that expresses in a way that the compute model itself can run and check which parts of the graph are reachable through this like look ahead mechanism that I want it to have. And then the condition bytecode has another property, which is that it should not change the state. So this is code that we run to figure out if we're allowed to go down the path, but it's sort of supposed to be have no side effects. And so that could mean one of several different things, which I have not chosen which way I would want to go with this. It could mean that it only has access to a subset of instructions, like maybe it can modify the registers but not the memory, and then the registers are automatically restored like after the bytecode has run. It might be that it goes through the VM like reversibility paths, so you run the condition bytecode and then you reverse it using the whole reversing system. Not quite sure. But something like that. The state of what the current state of the VM at the initial node is restored after each path is condition checked. And then once we know that a path can be taken, it has some execution bytecode, and that actually can have side effects. That can do things. That can even emit some content. So when you have execution bytecode on a path, you can also have execution bytecode on a state. And that decides whether or not to emit content. And if it does choose to emit content, then you have to stop there and you can't look ahead any further. If it does not choose to emit content, then you can keep looking ahead. Now, there are other conditions where we want to check and say like, oh, we don't actually want to look ahead any farther than this, but this isn't necessarily content either. And that's stuff like pushing onto the graph or popping off the graph, right? So you can't look ahead past those things in my current thinking. But I think there might be some problems with that. Like I'm just saying that because I think it's a good rule to start with to limit the complexity. But there might be good, like I said before, there might be good reasons to keep looking ahead through stack operations and stuff. So there are different things that stop the look ahead process. And emitting content is one of them. But emitting content is now in the bytecode. So instead of having content that is either attached or not attached, and whatever is attached is always the same thing, now content is arrived at procedurally through the bytecode. And that will mean that we can do things like, oh, hey, this node looks at the state of the graph and sees that the counter over here says 0, so it's going to increment that to a 1 and then emit some content for an initial interaction. And then later it'll look and see that that's a 1 and increment it to a 2 and not emit anything because it doesn't have anything to emit when it's a 2. And as a side note here, I do also want there to be surprises where like it's possible that as an interface, I want to suggest that you're going to the tavern and buying an ale all in one button click, but I actually intend, like, the system has hidden in it random events that the player cannot predict. So they didn't know this was going to happen, but the story that gets told is, hey, I'm going to go to the tavern and get ale. And it's like you set that intention, it's on its way to do that, but instead of going to the tavern and getting ale, when you arrive at the tavern, some content happens, and it's content you didn't expect. And so for that, I might need an emit that also does not stop look ahead. But when you attempt to interact with the button that would take you all the way to buying ale, what it's actually going to do is run the execution path towards that, and when it finds one of those hidden emits, it still stops. So it's like I need an instruction that says, when we are actually deciding what to show to the player, show something from this node, but when we're running look ahead, hide it so that the player can be surprised. Okay. With that, we've looked through this entire to-do list. Like I said, number 6 was where we started, so you already understand what I mean by look ahead. That's all of the other pieces are building up towards making look ahead possible. And if you want to remember what I meant by look ahead, it's earlier in the video. Now, I have one last thing I want to go over here, which is all of this is theoretical in the sense that I've just whiteboarded out the ideas. I have not built it, so I don't know if it works like literally, and I also don't know if it works as in does it make a good structure in which to author the kinds of things I envision. And I want to talk about that a little bit before I'm done. So where I'm at is I started off with a vision for what I want the particular prototype game to feel like, and what principle I would use to try to build it, which is, I did the 7-day jam, saw some problems, got to thinking that maybe what I needed was something a little more structured for controlling the game state, and went with the story graph thing. And in some ways that has helpfully structured the exploration, but I also have no proof that this is the right path to be on. Like, some of these ideas are very exciting and intriguing, and I want to play with them a bit more and see how it feels to write stories within these ideas I've explained. But there's also the possibility that I am throwing more and more and more power at this because I am looking for it to start doing something that it's just not going to be able to do. And I'm not disheartened here, if it sounds like that. I'm more trying to prepare for a different kind of move in this project, which is I'm at a point where the level of complexity that I'm proposing for the next step is going to take me weeks to build. And if I build all of it and then I start adding content on top and I hit more issues again, that might be an indication that I want to take a bigger step back and look at it a different way. It's always hard to tell in a sort of explorative project when it's the right time to bail on an initial idea that you wanted to work on. And I've been trying to work on this story graph this whole time, basically since the end of the first week of the jam, right? So ever since I started these unscripted videos, I've kind of taken the story graph as the piece I wanted to work within or like build on. And there's a couple of reasons why I thought that was a good idea. One of them being that it's a familiar interface to other kinds of interactive fiction authors. So if a story graph was a useful structure, or could become a very useful structure, it would also be familiar to them. And that would mean that people who are already interested in authoring this kind of stuff would have a good starting point with this tool. I had some other ideas that I don't need to fully rehearse again here, but it's possible that the story graphs don't get the job done. And the only way I would find that out is by taking a big step back, because I can spend forever throwing more and more features at a story engine built on story graphs, looking for a way to make it come to life. And I might eventually find it just by attaching enough code. And at some point, once you start attaching code to your structure, there's no limit to how much magic you can smuggle in through that code. And it's useful to take a step back at times like that and ask, is it the story graph structure that's making any of this magic? Or have I just smuggled all the magic in through the execution model in the bytecode level? Like, am I just programming in the magic manually at this point? And if I am, is there a more streamlined way to organize that process? And my basic plan here is this. I want to build everything I've proposed, and see how it feels to work with it. And my metric for whether or not it's good enough can't be if it's got any friction, then I'm done, because the friction might be that there are lots of little failures in the design that just are small scale failures, that the large scale ideas are working. So it's not whether or not there's friction that I can use to give me this test, but what I need to kind of be prepared to notice overall, am I able to do things now that I would have a hard time organizing without this graph structure, right? Like I need some way to answer that. And it's a little hard to think of like what my exact litmus test can be, but I need to like prepare for answering that question somehow. And I'm thinking that the test has to be something like, well, the ultimate test would be to go back and write something similar to my prototype. Like if whatever prototype I end up with after this, right? Could I go back and write the same exact prototype or get something that feels very, very similar without using the story engine that I built and just directly coding it some other way, like starting from scratch, knowing how I want the prototype to behave, just code it into C, make it behave that way. Is there some way I could do that would be pretty easy to do? And if I did that and compared the iteration process of that versus the iteration process of what I have now, that could inform some stuff. But there's a separate issue there, which is if I copy the story, then I'm kind of skipping the iteration on the story, right? A part of what the story engine is supposed to provide is a data structure that gives you useful intermediates from, like, so that, we talked about this before, your day one progress can be incomplete, but still progress that is not invalidated by the work you do on day two. And it might be that if I ditch the story engine but recreate the prototype, I just am using all the planning that I already have for the story details and game mechanics, but that I wouldn't be able to iterate from scratch in any way that is near close to as efficient as the way I could iterate with the story engine that I've built. And so it's still kind of hard to test. So I need to like think about, like, is there a way to test this? And by test it, I mean test if it's got any useful properties that weren't available before story graphs were a part of this picture, right? Like maybe the magic is in the reversibility of a VM, and that's it. And like I just need a VM with reversibility, or maybe I need a VM with reversibility and look ahead, and it isn't about a story graph. Although I don't know what structures the look ahead if it's not a graph, right? There's a question there. But like I got to try to identify what's making it magic and what's not. And so I guess I don't exactly have an answer here. I was hoping talking it out would bring something up. But it's something I want to start watching out for, because this one is a big push. It's going to take a while. I don't want to do lots and lots of these big pushes without examining the core assumptions that might be undermining progress at some point, right? So yeah, no easy solutions, but I have to watch out for getting stuck trying to make this story graph do something that isn't really the story graphs isn't really in the wheelhouse of what the story graph could even achieve. As a final note, since this is going to take so long, in my imagination at least, this is going to take a few weeks at the very least to implement all these ideas. I don't imagine that there's going to be another unscripted brainstorming session for a little while, because I'm just going to be heads down building this out, and there's not a lot of design left to talk about. It's more programming stuff. So if you're trying to follow along and you're not seeing these, it doesn't mean the project is dead. I will post an update as soon as I either give up on this path or finish it and have notes. All right. So I'll see you then.